Hello, everyone. Welcome to my presentation on boosting real-time e-commerce analytics with Apache Ignite on AWS, where, as the title suggests, is going to be me talking a bit about how we can particularly use Apache Ignite with AWS to be able to boost the performance of real-time e-commerce analytics, as well as, of course, construct the platform itself. And I'm Rinaldi, and I'm really excited to take you through this. So without further ado, we'll get straight into it. So I was already given a bit of an intro at the beginning, but I'll pretty much just say some fun facts, I would say, about myself. So I'm currently holding all 14 certifications from AWS. I'm currently an AWS community builder and am 20 times Microsoft Azure certified. I am an instructor and author. I'm the author of Amazon Bedrock in Action. I am also an international speaker who has spoken at over 50 different conferences and events. I'm the organizer of the Melbourne Python Meetup. And in general, I enjoy all things AWS, open source, generative AI, and virtual reality. So what kind of agenda are we looking at today? First, we're going to be talking a bit about the project requirements and objectives. So understanding a bit more on the specific requirements that will be underlying this particular project. We'll also be looking at what kind of objectives can be defined for this kind of project, and how we will define them is going to be a very important part of how we'll address it later on. We'll then look a bit into an overview of Apache Ignite and AWS services, getting a bit more understanding of why we choose these particular services for our particular task. We'll then go a bit into the system architecture and the data flow, understanding how the architecture is made up of the different services that we have chosen, and the flow of data that moves from one part of the architecture to another. Essentially understanding a bit more on how we will be building this from the ground up. We'll then look a bit into implementing real-time analytics, understanding how we can get monitoring and alerting in real time and the benefits that we get from it. We'll then look into some more performance optimization-based challenges. So things like scalability, fault tolerance, and optimization. We'll then look into monitoring and management. And finally, we'll look into key results that we can get from this kind of project, as well as future considerations. So a bit more introduction and essentially setting a bit more context into what we'll be talking about today. As a primary goal, we really want to be able to demonstrate how an e-commerce company pretty much builds a high performance real-time analytics platform. So in this case, the company was pretty much one of the clients I've taken on in the past, and essentially I'm going to be using this particular case as a case study. And what are the key focus areas that we're looking at? Really on architecture, understanding what kind of data processing techniques we'll be working with, as well as how we can optimize performance of these systems that we are working with. So what were the requirements of this particular project? Well, to start off with, there was a lot of high velocity data, and you can expect this from a typical e-commerce site, especially when it comes to peak seasons. For instance, say holiday periods, when everyone is trying to shop for something during the holiday period. These kind of things are all part of high velocity data. So things such as user interactions, transaction logs, inventory updates, these are all factored in as part of the high velocity data that occurs. Aside from that, we also have real-time insights. So you want to be able to monitor KPIs, understand things such as, for instance, conversion rates, inventory levels, customer behavior. And as mentioned before, because of things like peak traffic periods, such as, for instance, Black Friday, we need to be able to consider scalability considerations. So understanding how we're able to balance that scalability of different kinds of how we're handling different loads is a very important thing. Finally, we need to be able to ensure that we have high availability. So things such as in terms of minimizing downtime and data consistency. And what are our objectives looking like? So our objectives itself are pretty much comprised of different key elements that really help us stay on track of our implementation. So rapid data processing is one, since we need sub-second latency for analytics queries. When we get much transactions happening within a short-term period, we need to be able to have this kind of latency to be able to factor in for many different transactions and many different potential decisions that we need to take within a short period of time to be able to take action on them. Aside from that, we also want a streamlined architecture. We want a seamless data flow from ingestion to visualization. We want to be able to have the data flow without any issues, any errors, any bottlenecks. We want it to be able to be processed fully as we need so that we can take decisions directly based on the visualization that we have. Being able to visualize accurate data is a very important thing. And those pretty much who do data analysis probably understand this quite a lot, but it's very important to ensure that your data is kept clean and ready for this kind of processing so that there are no issues when it goes up to visualization. And of course, as the architects of this particular infrastructure, it is our duty as well to ensure that the architecture does support this kind of seamless data flow so that we won't have any issues later on when we actually go into the implementation. Aside from that, the operational efficiency is another very important objective. We need to ensure that we have automated scaling and proactive monitoring. We want to be able to continuously have a bit of an autonomous infrastructure to be able to ensure that when we scale our services, we can essentially expect it to work autonomously instead of us having to do it manually. And of course, having proactive monitoring in terms of being able to monitor ahead of potential disasters that might appear later on. Finally, of course, we have business impact, which we want to be able to enable data-driven decisions to be able to boost sales. That's a very key factor of what we're looking at today, because one of the parts of being able to optimize performance in these kinds of scenarios is because we want to be able to have better decision making being taken place. And we really need to be able to ensure that what we are doing with the system can really boost that capability. That is essentially what will set out a system compared to like another e-commerce system that might also exist and pretty much be dealing in the same stuff. And why Apache Ignite in particular? So in-memory data grid is one thing. We're able to get low latency reads and writes for real-time processing, which is a very big factor in which Apache Ignite is able to provide. As I mentioned before, latency is always a key consideration and a key challenge in working with high velocity data. And with the in-memory data grid, Apache Ignite is able to help with this quite a bit. Distributed SQL is another factor, since we are able to simplify complex queries at scale. Compute grid is another important factor, as we're able to parallelize the different execution that we have with the different analytical tasks that might be taking place. This is a very important thing, especially when we consider that there are going to be a lot of different activities that are happening at the same time, as expected from an e-commerce platform. Finally, streaming capabilities, because we can have continuous data ingestion with minimal overhead. We'll see a bit more as well about how the AWS ecosystem helps with this as well, particularly in facilitating for really smooth data ingestion over a long period of time. And we'll explore that a bit more when we go into the architecture. Now, over to the other side. Why AWS? Well, firstly, because of its key services that we're looking at that can facilitate for the whole architecture process that is pretty much created. So Amazon EC2 is one of the key services that is part of this. We're able to have scalable compute resources for Ignite nodes with EC2s. So it really helps in being able to create the autonomous scaling that we wanted, as mentioned before. We can also have Amazon S3, in which we can have durable storage for raw data and backups. And another good thing about the S3 is because it's pretty much a pay as you go. So it's a really great way of being able to be cost efficient in terms of storage. AWS Lambda, we want to be able to have this to be able to facilitate for event-driven data ingestion and transformations. Finally, we can have AWS auto-scaling. And this pretty much is based on the EC2s because we can dynamically scale the Ignite cluster based on the demand that we have so that we are not wasting our cost willy-nilly, but we are being cost efficient through dynamically scaling according to how much demand we actually have. And this is one of the key advantages of being able to host this on AWS. In terms of the high-level architecture, we have a few key things that I'd like to mention. And we'll explore this as well in a bit when we look at the actual architecture. But to start off with, we have data producers, we have the e-commerce platform, transaction logs, clickstream feeds. This all are very important factors as part of being data producers because we can have the appropriate platform provide the relevant data and transaction logs and clickstream feeds. This all is going to be fed from the e-commerce platform essentially producing the data. We then have the streaming layer, in which case the AWS Lambda functions push the data into the Ignite clusters. We then have the Apache Ignite cluster, which is serving as the in-memory data and compute grid for performing real-time analytics. And finally, we have the analytics dashboards. And this is where we do our visualization. We have visualization of the relevant KPIs that are going to be shown in real time with Ignite SQL. And this just makes things much easier because we facilitate for this in real time and ensure that we are continuously pushing data and visualizing it so that we are able to make decisions quickly. This does not only help with making decisions for important, for instance, products that are to be sold or when to, for instance, raise the price on certain products, but it also allows you to be alerted to certain things that might not exactly be as what is expected. For instance, say if KPI or a metric goes above a certain threshold, for instance, well, this is certainly something to look into that we can pretty much just get alerted to and quickly take action on. And here's the architecture diagram that I was mentioning before. So we can see that this is quite a high-level diagram of how we look at the different interactions and the data flows that take place within this kind of architecture. So as you can see over there, we have data in the form of inventory updates, transaction logs, user interactions. So these all produce stock changes, order data, and clickstream data respectively. This all gets fed into Amazon Kinesis, which ingests that and triggers an event with an AWS Lambda. So this then sends it and pretty much transforms and cleans the data and stores it within Amazon S3. However, on the other hand, we also stream the data then to Ignite. And this goes into Apache Ignite Data Streamer. We then start feeding it into different nodes, which you can see over there. And this is where we start getting into the Apache Ignite cluster. And this is where I want to focus quite a bit of attention on because we have quite a bit going on here, as you can see over there. So we have the nodes ingesting from the data streamer into Apache Cache. So Ignite Node 1, Ignite Node 2, Ignite Node 3, these nodes are ingesting this particular data into them. And with that, we also replicate data for in terms of availability and consistency. And this is then sent into a compute grid, which is going to serve as a fat client in this case. So this is going to be sent there essentially to be able to perform the relevant aggregations and the relevant compute. And this will essentially then have it sent into the Ignite persistent store. So for relevant aggregations, for relevant storage. So pretty much we're having it as a persistent store, and we then save it as a relevant backups within S3. On the other hand, we also send the data into SQL Engine Fat Client, which serves as a Fat client. And this will serve as a way of being able to run the complex queries, which I was mentioning before. As I mentioned before, we want to be able to facilitate for this kind of processing and complex queries. So the SQL engine helps a lot in being able to do this. And as I mentioned just now as well, the great benefit that we have from having these nodes is that we can perform auto scaling on them. So they will scale automatically based on the load that we currently have. And we'll talk about auto scaling in a bit again, but I just want to highlight the benefit more or less that it provides, just because the scaling really provides a potential for being able to take on more loads and is able to do it autonomously based on the load that we get. We can then visualize the results that we get in terms of the SQL client through a JDBC or ODBC connection. And this goes into BI analytics dashboards or external BI tools. And this stands then to be visualized within these particular tools so that we can see these particular interactions and data and results taking place. And this is where we then see the end visualizations that we have been talking about, because they can be visualized and we can then make decisions based on them. Finally, as the last part of the architecture, we also get the Ignite metrics as well. And this is where we log the different kinds of metrics. And it really is comprised of a few different things. So it could be, for instance, from the CPUs or the memory that's taken up by the EC2s that's running. Or if you, for instance, install like a CloudWatch agent into like the EC2s, you can pretty much also log in the relevant custom metrics as well and keep track of things through CloudWatch. Accordingly, we can also set up the relevant alerting too through AWS SNS. And that's where we get the alerting. We can configure it to go to our email, to our phone. So really just depending on what the preference is. But it really helps to be able to be alerted when there are certain thresholds that are passed. So that's more or less a quick walkthrough of the architecture diagram. As you can see, there's quite a bit of moving parts, but it's meant to serve as a great way of being able to maintain the architecture and just serve as a great way to visualize the data flows that's going through the architecture. Now, let's put our magnifying glass a bit more on the data ingestion and processing flow. So, a few key things to note here. Firstly, there's event triggers. As mentioned before, AWS Lambda is going to be invoked by new events. Just for instance, if there's going to be new data put into S3 or Kinesis ingests something new, pretty much triggers Amazon AWS Lambda and accordingly gets invoked that way. We get transformation as well being performed, and this takes place in the form of basic cleanup or enrichment before we then start loading it into Ignite. We then have Ignite streamers, essentially batch or streaming APIs, to be able to handle continuous data that goes through. And accordingly, we then start to configure Ignite to handle different spikes without data loss. So in a way, we're performing a bit of buffer management. And code below pretty much just shows a bit of how the data streamer would look like in this case. So we pretty much are using a data streamer. We're allowing an override on the streamer. We're then just adding the data based on the streamer and accordingly returning an OK if it pretty much runs according as necessary. Now, another key factor of this is real-time analytics with Ignite. As I was mentioning before, it's very important that we understand and achieve how real-time analytics can be done within the Ignite environment. We can have SQL queries in terms of ad hoc or scheduled queries over Ignite's in-memory tables. And as I mentioned before, this is one of the main things of why Ignite is very important to be used for this use case. We can have compute grid tasks in which parallel computations are done in terms of session tracking, predictive analytics, and much more, of course. These are just some examples. We also are able to get dynamic dashboards, and this is where we look at auto-refreshing the different KPI charts with the query results that we already have. And of course, this comes as well hand in hand with being able to then integrate with different JDBC and ODBC connectors for BI tools so that we can visualize results in real time or at least near real time. As I mentioned before, it's very important to get this kind of information quickly, and we're able to look at these kinds of metrics quickly that way. And as you can see over at the left side, there's just a bit of sample query in terms of SQL. And as you can see, we're caching it particularly with Ignite. We're creating a new query, and a key highlight that I want to put is that we're setting it to co-located as well. This helps to optimize the query that way, and yeah, pretty much like perform a get all that way. So a few other things from Ignite's features that we are looking at leveraging. Caching. We've mentioned that a few times before, and distributed caching in particular really helps a lot because we're able to partition the data across the different cluster nodes. It really helps in being able to get the data accordingly partitioned and basically just set apart that way. Of course, then we can move on to data partitioning, in which we're able to shard the different user transactions for different concurrent accesses that are made. We can then look into co-located processing, in which we look at executing compute tasks on nodes where the data resides. And as you can imagine, this provides many benefits in terms of how we are particularly getting the data to appropriately work based on the where the tasks that are currently being performed. And this makes the latency overall just much faster that way. Finally, we get persistent store, which is what we really have with the native ability of Ignite to be able to have the persistence for performing quick restarts. Scalability is a key concern, as I mentioned before, because as loads continue to grow, we'll also need to have approaches to scalability that will continually be up to par into where we are looking at. So node scaling is one key aspect. EC2-based clusters, for instance, is able to expand or contract with AWS autoscaling. And that's the main reason why we're using EC2s as well, because we can accordingly scale it. So not only does it provide the appropriate compute for us and run clusters, but it's also able to provide us the relevant scaling when we're looking at that. We can then also look at data partitioning, in which we want to be able to have distributions, even distributions, which prevents node hotspots. We also want to look at having potential for automated deployment. So one key concern with these kinds of deployments is consistency. Sometimes there might be human errors, sometimes there might be inconsistencies in how things are provisioned, maybe through ClickOps. So having services such as AWS CloudFormation or Terraform templates is able to help out with this a lot. Horizontal versus vertical is actually a very important problem that I would say is quite a bit debated, quite a bit in the Ignite community, I would say, because within this scaling, it makes more sense pretty much to put in the horizontal based scaling. And the reason for that is Ignite's the dynamic rebalancing helps to redistribute partitions automatically as nodes are added or removed, which makes it more seamless than the traditional sharding. So this is usually important for increasing the relevant concurrent queries and being able to also support compute capacities. And more or less, it's more resilient compared to vertical scaling, in which you're allowing for larger partitions per node and potentially better single node performance, because with failures affecting fewer partitions, you're able to pretty much have it be more resilient that way compared to vertical scaling, which risks node failure, which causes larger disruptions. And you particularly have Ignite also helping to minimize cross-node data movement, and hence have partition-aware queries, which are optimized for horizontal scaling in that way. So in this case, I would say that especially with write-heavy workloads, they benefit more from horizontal scaling because transactions are going to be more evenly distributed this way. So this is a bit of a background, I would say, in horizontal versus vertical. It's always on a case-by-case basis, but at least on my own use cases, I've always just found horizontal more preferable compared to vertical scaling. So fault tolerance is another key concern that we pretty much will address here as well. So replicated caches is a very important part of this because we can particularly have critical data that require high availability to be able to be replicated across the different caches. Because Ignite helps you pretty much as well to configure the relevant backup caches as well for different partitions. And of course, if a node fails, partitions are instantly available on another node. And that being said, it's always good to maintain a good amount of backups because too many backups will also just increase memory storage too much. What we really are after, though, is the auto healing that we can have because we are, as I mentioned before, can replace the failed nodes automatically. We also can get different Ignite backups that way, and pretty much just ensures that we are configuring the overall backup count as well, which will ensure that the data accessibility will continue on being a factor that we continue having. So that's a bit about fault tolerance and why we are looking at that and how we essentially are achieving it through Ignite. Now, optimal performance, as I mentioned before, is another very important consideration and what is also achieved from this particular architecture. Data partitioning, in which we are particularly wanting to fine tune the partition count to balance the node load, essentially, and have higher partition counts with lower partition sizes, is always a very important thing that we want to look at. We need to be able to consider a few factors in this, including being able to ensure an even number of nodes, uh, for instance, like per availability zone. And we want to be able to ensure that we have the appropriate number of partition counts this way. We want to also ensure that we are performing the relevant indexing, that we are creating the relevant secondary indexes on the appropriate high traffic fields, for instance, like product ID with user ID. So this helps to be able to optimize the performance in general when we are actually performing queries, especially when it comes to complex queries. We can then perform a bit of query tuning too, in which we are performing co-located joins, avoiding relevant full scans, and help to also configure the network as well, such as being able to optimize the AWS networking parameters for Ignite traffic in particular. We can then also look at different partitioning considerations as well. So partition mapping is a very important thing. So each partition in this case would pretty much be assigned to a relevant primary and backup node. We can then combine that with the strategy of having composite indexes. So combine different columns such as user ID and timestamp and have them done for faster lookups. We then can also use a query planner analysis in which we look at profiling queries to detect bottlenecks that might happen. This helps us to identify potential issues that will happen rather than have to face it later on when we actually do get into that bottleneck. And it's a very common SQL tactic as well to employ in general. And we can also have the continuous improvement of being able to also reindex after seeing the evolving usage patterns. It's always a continuous process because we always see that, okay, at this point we might be encountering this particular issue, but later on it might not be as relevant because we might be encountering a different issue. And we just need to tailor it based on our own use case and based on the patterns that we see based on user usage. And we can just see it in the code example, for instance, that we're creating a new query entity and we're setting the relevant indexes based on product ID and user ID within a list and appropriately just returning that. Monitoring and logging is also equally as imperative to consider. We need to be able to ensure that we are monitoring the relevant CPU, memory, and network usage because this helps us to also understand our usage patterns and where we are able to optimize further and understand how we can better utilize these kinds of resources. It's very important from a cost management perspective that we ensure that these resources are kept in check. We also can look at the Ignite Management Console in which we track the relevant cache matrix, query times, cluster topology changes, which is to name a few. There are still many more metrics that can be tracked from that, but these are very important things to keep in track in general. We can set custom alerts in general for threshold-based notifications for anomalies. As I mentioned, could be logged in CloudWatch, could be seen from Management Console. This is a very important thing. And we can have centralized logs, which can be aggregated within S3 for looking at troubleshooting and relevant audits. Some operational best practices: use infrastructure as a code, maintain consistency with CloudFormation and Terraform, as I mentioned before, get rolling updates to be done, upgrade the relevant Ignite nodes without taking down the entire cluster is a very important thing, especially when you consider looking at how you are continuously going to provide relevant updates and what is your availability SLAs that you have for the website. Like, these are considerations that you have to keep in mind. Security. So in AWS, you can have AWS IAM roles for restricted S3 and network access. And you pretty much need the relevant backup and restore, as I mentioned before, with having the relevant periodic snapshots, which are saved in S3, to be able to be then spun up for quick recovery when needed. So what are some challenges that are faced? And as you can imagine, these kinds of things definitely have a number of challenges that are encountered during the process. So in my case itself, when I was pretty much having a bit of the look at the data spike handling, I needed a bit of a robust stream buffering and essentially had a bit of back pressure as well in doing this. So what really went wrong was that the data streamer in this case couldn't keep up and partitions started queuing. And the query latencies, as you can imagine, would also shoot up as well, which affects the overall real-time analytics dashboards. So because of the sudden spike, the backup partitions were replicating a bit too aggressively, which caused unnecessary data movement across the nodes. So an easy equation that I would give would be more data equals to more memory churn equals to longer garbage collection pauses equals to more lag. So what did we do to fix it? We enabled batch data ingestion. Instead of inserting transactions one by one, we switched to larger batch sizes in the Ignite data streamer, for instance. And what we then did was that we adjusted the backup replication strategy initially, backups were replicating instantly, but we then introduced a delay-based replication policy, which was able to reduce the unnecessary network load. We then optimized the off-heap memory usage, in which we enabled Ignite's native persistence for part of the data set and ensured that in-memory operations were not overloaded. And finally, we just implemented a bit of query throttling at the API level, which was able to nicely prevent sudden spikes from overwhelming the system. And that really helped a lot overall in the system when we looked at optimizing it that way. Aside from that, we were also able to do a bit more optimization in terms of schema evolution. So how we were able to manage the different stable schema changes carefully was something that we really learned along the way too. And in general, just some best practices that we also picked up along the way. And I suppose is pretty much good to mention here as well is just to never, for instance, like never drop columns. Instead of like deleting a column, make sure that you're keeping it in the schema for backward compatibility. If the column's no longer needed, then stop using it within queries. Rename the columns by adding a new one, for instance, if you need. So pretty much like create a new column with the desired name instead of, pretty much by adding a new one that way, and update the application logic to read from the new column while still supporting the old one during the transition. So once the relevant code is migrated, then you can look at deprecating the old column. So these are pretty much like a couple. I can think of some more, for instance, like always appending new columns like at the end and avoiding select star queries. These are pretty much also pretty traditional SQL based suggestions, but these certainly do go a long way when you look at evolving your schema. Aside from that, cost optimization is another key thing. Right sizing EC2 instances, using spot instances for development test environments because they aren't as important and not as critical to save costs. So it really goes a long way. And finally, just make sure you have the relevant team upskilling and getting the relevant training for Ignite's advanced features, which will reduce a lot of trial and error along the way. So what were the results and the business impact? Well, faster decisions is the first one because we can get sub-second responses for critical KPIs. We're able to increase the sales as well that we saw for the clients. So we got improved personalization and reduced cart abandonment because of the performance that we have and also how we're able to personalize it better that way. We also get enhanced user experience. We can get real-time inventory, fewer stockouts that can happen from it. And finally, we get more operational efficiency because we're getting the proactive issue resolution that way from being able to more quickly identify particular issues and be alerted to them and get minimal manual intervention that is needed. So what are some next steps? Well, I would say it definitely has a number of potential future enhancements. Firstly, in terms of how we can leverage AI and ML. As you can already tell from today's world, there's already a lot of talks about how you're better enhancing your products, better enhancing your organization with AI, with ML, and this is no different. You can have ML pipeline integration, for instance, being able to better detect anomalies in terms of pipelines. Or you can also look at getting AI-driven recommendations, how you can get more personalization from being able to recommend different products for your site. Or maybe even in terms of how you can better optimize your system based on AI recommendations. And of course, there's also broader applications to look at as well, such as, for instance, better session storage, potential fraud detection where you're looking at transactions, recommendation engines that can be used to be able to personalize the experience. But these are all pretty much out of scope. These are things that we're still thinking about, but they definitely could boost the performance and the overall effectiveness of such a system. So that is all for me. Thank you so much for listening to my talk. And if you want to reach out to me, I'm happy to pretty much have any of the socials after, if you want to reach out after the summit. Otherwise, happy to take up any questions as well now.